getting underway. Okay, great. So tonight we're continuing with our study unit 6 on normal distribution. We'll finish that, and then we will also look at some of the examples that was done in your assignment 2. And as people join later, I will just ask 1 or 2 questions around that. But let's start off by looking at the last part of study unit 6 on a normal distribution. And again, just to reiterate the importance of study unit 6, because study unit 7, 8 will also use the information around study unit 6, study unit 9 as well when we go into hypothesis testing. So very important, the impact of study unit 6 on the next 3 study units. Okay, so the next question that we are looking at is another one where, like last week when we looked at it, where they actually give you a Z, and here they tell us what that Z is, and we need to find what the probability is. Again, for me, the not just the easiest way, nearly the only way I can look at the Z and how I can merely work with it is when I draw a diagram. We remember that if you look at the Z distribution, remember in the middle the mean is always 0, and here they also actually tell us this, but else we always know that when you're working with Z, the mean is in the middle. They want us to look at the minus 1.59, so at minus 1.59, and then they also tell us that it needs to be smaller than. So basically they're asking us to work out the probability that Z is smaller than 1.59. Okay, so again, before we even go to the tables, a few things that we can look at. Probability must always be between 0 and 1. It can't be negative. So if we don't know the answer, at least we know it can't be negative. So we can eliminate option 5 already. Then remember that because when it is normally distributed, we're working with a normal distribution that is symmetrical. So left to the line, or where the mean is 0, will be 0.5. Right to that line of 0 will also be 0.5. So when we look at this small area that we need to find, we can see that it will be smaller than 0.5. So again, if you look at your options, smaller than 0.5, we can't have option 1 in there because that one is bigger than 0.5. So at least we are sitting now with only 3 that we need to work with instead of 5 options. Okay, then we're now looking for negative 1.59. So again, you guys will have this in your study guide. Um, we will probably get from a lecturer also a combined tables with formulas for the exam, but also important, nearly it's sometimes easier if it is also printed. So if you can get it printed somewhere, and it doesn't need to be the whole study guide, it can just be the tables. So we need to look for minus 1.59. So we will, again, we look at it, the first two, so the first number after the decimal, that is how we will go down with it. So we need to go down to minus 1.5. So if we go down to minus 1.5, we will go across to the second decimal. So it was minus 1.59. And then where those two meet, so from there and there, we get the probability that we are looking for. So 0.0559. 0.0559. Okay, so here is just also for you guys a smaller version of the Z table. So again, you could see, and let me explain it also this way. So the numbers going down is this first two. The numbers going across is this one. Okay, so we are looking at 1.5 or minus 1.5 as we go down. Go down, down. So where it's minus 1.5. Then we go across to where it is 0.09. And where those two meet, you will see also then that we get 0.0559. Okay, so this one, they gave us the Z. We needed to get the probability. So once again, there's two ways in study unit 6 that they can ask you. They can give you the Z, like here, or they can give you the information to calculate the Z so that you can get to a probability. Okay, so that will be the two ways for you in study unit 6 to nearly work out the probabilities. Either they give the Z, like in option or question 3, or they would give you the mean, the standard deviation, and X so that you can work out the Z to get to the probability. Okay, so let's get to the next question. So here they give you a bit more information. So they tell us X is normally distributed with a mean of 100 and standard deviation. Okay, so let me I'm just hoping. Ooh, okay, so there was supposed to be more information in here. Okay, so this is not really going to work. I will need to find out what this question was. So let me just check what I can get. I have it, so not to worry. I just want to see what So let me just get what the standard deviation was. Okay, that was 1 with being 100. Question 4. Okay, standard deviation was equal to 20. Okay, so just important. Okay, so let's just include that. Standard deviation was equal to 20. Okay. So in this one, again, we need to work out the probability. They don't tell us Z, so we will need to calculate the Z. And then they tell us normally distributed and standard, which is greater. Okay. So my answer will be bigger than, greater than. And then let's see. So if we look at the formula, I'll also share the formula page later with you guys. X minus, so X is 145, minus the mean, which is 100, divided by standard deviation, that is 20. So that looks like 45 over 20, which is, I think, 2.25, but let me just, 2.25. So we're looking for a Z that is bigger than 2.25. So if we draw the diagram again for us, it will be that small area. So now, unfortunately, when we go to this table, we work with the positive, we see that we actually getting the left side of that. So the table is going to give us this side. Okay. So let me just, so the table is going to give us this. But we want the other small area. So what we can do to get that small area, and let's make it just another color. So if I want to get the purple area, we need to remember some of the rules of probability and specifically normal distribution. So the total probability below the curve is equal to 1. So to get that purple area, we can just say 1 minus the red part. Okay, so 1 minus the red part will give us that. So we know that we can look at Z is bigger than 2.25. So let's look at 2.25. So we go down to 2.2. We go across to 0.005. Okay, so let's see. So that is the number that we're looking for. So we will need to say 1 minus 0.9878 to get our purple part. Just be very careful. Again, exam time, also when you do it in your assignment, pressed for time, you see, well, cool, I got 0.9878, first option, mark it, you go off, you think you're correct. But remember, it's actually 1 minus that will be the correct one. So it's not that one. Also, what we could have seen is that we're working with something that needs to be smaller than 0.5. So that's smaller than 0.5. That's smaller than 0.5. So we could have eliminated the other two as well. Okay, so 1 minus 0.9878 will give us 0.0122. Let's sure that that is 0. Okay, so we've got the final answer as 0.0122, which is option 5. Okay, so that again, this time you needed to work out the Z. They give you all the information. They will always give you all the information if you need to calculate the Z. And then with the Z that you basically calculated, you then need to look at the probability. What can also happen, and again, this is just out of experience, is that one of the options might also even be the 2.25. So again, just because you're working it out, you nearly forget that you need to work out something more to this. You pick the 2.25, you go to the next question. Remember, again, like in your assignments, that's how the exam will also be. If you're done with a question, you can't return to the question again. So if you make a mistake and you don't realize it, you can't go back to correct it again. Okay, let me quickly get a feel and to check in with you guys on this so far. Is it at least okay? Do you understand? Is there things that we need to? Yes, Ian.
Like, where did you get the standard deviation from? Because I started a bit late.
Okay, no. So I unfortunately it was cut off. So I just quickly went to look at the question again, to get it. So again, it needs to be part of a question. So unfortunately, it's sitting behind this table, and I could not get to it.
Okay.
Sorry, Ian. Okay, cool. So that is why they need to give you the standard deviation. They need to give you the X, and they need to give you the mean. When we get to study unit 7, then there's something that they might bring in around the standard deviation, and that you need to bring in a sample size, but we'll get to that the next time around. But when you need to calculate Z, that is what you need to have in the question. Okay, let's look at the next one. Okay, so let me quickly just cover up these answers. Okay, so sometimes they give us the information, and I think you've seen it now in assignment 2, where they've asked a bit differently with permutations, and they bring in some of the notation. So the notation that is now a bit different, and sometimes you don't know if you would have seen it. I don't know if it's in the study guide in some of the questions. It might be, and it will definitely be in your books. So what they're looking at here is to say, and again, could have used words for this, but they say that considering the following statement, if X is normal distributed, so that N is actually saying to us it's normally distributed with a mean of 15 and a standard deviation of 25. Okay, so I think that one is important that we nearly look at that, because sometimes they don't give you all of these notations. So I will also just make sure I'll go through the study guide later again to see if I have included in the study guide, but I haven't seen it in the study guide. So just important that you guys have that. Okay, so let's just do that. So let me just make sure. Okay, so it is not, sorry. So it's always, so let me write it here as well. Mean and variance. Okay, so if we want to get to the standard deviation, remember the standard deviation is the square root of the variance. Okay, so in this example, there's a few things that we can now look at. So we can, the easiest one to check is nearly this one, and we can look at it at both nearly at the same time. So we need to calculate a Z. Then from the Z, we need to go to the table. Okay, so let's calculate the Z for option C first. So Z is equal to the X. The X is 10 minus the mean, which is 15, divided by the square root of the variance, or just what we call standard deviation, which is 5. Okay, so already when you see that, your Z is going to be negative, which is fine. So 10 minus 15 is minus 5 over 5. So Z is equal to minus 1. Okay, so when we look at our diagram, and that is where it bombs out every time, so I will just need to see what that, but so again, now we look at the diagram, we know that there's the mean is 0, so we look at minus 1. Okay, so we need to look at minus 1. The one area is going to be the small area, so probably D. The bigger area will be hopefully option C. Okay, so minus 1 on the dot, so we will be looking at minus 1.00. So let's go to the table. We go to minus 1, minus 1.00. Okay, so there's the 0.00. So it's that first number. So 0.1587. Okay, so when it's smaller than 10, 1.587, perfect. When it is bigger, and now need to find out what is that bigger. So that is 1 minus 0.1587. Okay, so if we do that, hopefully we will get 10.8413, but let's just make sure. Okay, so that is also correct, because if we say 1 minus 0.1587, it gives us the 0.8413. And you could have then just checked again, if you add those two together, it must give you 1. Okay, so those two are already correct. So which of the statements A to E is incorrect? Okay, so it's not C, it's not D. So we know that if it's bigger than 10 or smaller than 10, sure. Okay, let's see if it's 20, what we will get. So x smaller than 20, so we will need to work it out again. 20 minus 15 actually becomes plus 5. Okay, then plus 5 divided by 5 gives us 1. So now we're just sitting on the other side of a symmetrical 0. So if we now sit on that side, this small area will be 1,587 because it's symmetrical. So if that was 1, or 0,1587, this side must also be 0,1587 because it's a normal distribution. It is symmetrical. And then if that is 0,1587, this area will be 0,8413. So that is actually also correct. I wanted nearly to say that must be wrong because I thought if you look at those two, I wanted to say it can't be the same, but I didn't realize it is actually sitting on the symmetrical side of 0 on your normal distribution. Okay, so A is also correct. So at the moment, it might be B or none of them. That is incorrect. So unfortunately, we will need to work out option B as well. So option B looks a bit differently. So option B tells us, okay, but your x is 0. So if your x is 0, 0 minus 15 is minus 15. So minus 15 divided by 5 is actually minus 3. So minus 3.00. Okay, so this time we're looking for x that is smaller than minus 3. Sure. Okay, so it becomes very small on that side. So that might even be correct. So if we look at the table, need to look at minus 3, so minus 3.00. So minus 3.00, 0.0013. 0.0013, which is also correct. So none of them is actually incorrect. Okay. And just to, when I share it, I will also share these answers with you that you can also then look at it. Okay, but This one was, this was not difficult, but it's very time consuming. If you look at how easy it was in question 20, this one where we just calculated, we looked at the Z, we looked at the table, we could find it. Here we calculated the Z, um, went to the table. In this one, you needed to nearly work it out 4 times, um, and then get to an answer. So a bit more time involved with this question, but I think also it is definitely important because I have seen that you can get a question that has 2 or 3 Z that you need to look at. Okay, questions on this question. There's still a few that we will work through, so okay, so let's just close that again, and then we can look at this again. So, okay, now we've seen that in this, when this paper was given, they love to work with that notation. So we now know that X is normally distributed with a mean of, and let's just write it in, a mean of 1.5 and a variance of 12. Okay. They tell us if that is that, and the standard deviation of a means of sample of size n from a population is 0.5, what's the value of n? Sure. And so if x is normally distributed and the standard deviation of a means of samples of size n from a population is that. Okay, this is actually, I'm going to mark it. This must be part of chapter 7. So I'll move it to chapter 7, and just why the difference between chapter 6 and chapter 7 nearly is that in chapter 7 we start working with samples. Chapter 6 was basically always looking at the population. So I will just move this to chapter 7 when we get there, and then we can explain it with the rest of chapter 7. But it has to do with the different formula that we will look at. So I just want to make sure that all of these must not then move to this one we can look at because you might have already gotten something like this in your assignment. So let's just look at this one. Okay, so they tell us a certain agency for the intelligence scale for children has a mean of 100. Okay, so let's do this. Has a mean of 100. And a variance of 2 to 5. If 2 to 5 is the variance, the standard deviation is 15. Okay, so that is thus for the formula. If a child falls in the lowest 10% of a population, a certain clinical psychologist routinely urges the child's parents to have a child tested for brain damage, assuming that the scores are normally distributions. What is the cutoff score for the psychologist using? Okay, so every time I draw the graph. Okay, so they tell us if a child falls within the lowest 10%. Okay, so that will be the lowest 10%. Okay, so we will need to get what that Z is. Okay, so if we go to the table, we don't know the Z, we want to get to the Z. What we know is that in this, I must look for 10%. So 10% is, and let's quickly see if I can write on this. Why can't I write on this now? Okay, let's just then do it here. So 10%, if it's underneath the graph, is 0.1. So in this table, we need to look for 0.1. And so let's see where it goes. 0.08, 0.01, 3, 6, 2, 0.1, 0.1, 0.1. Okay, there's also 0.1s. Zero, 119, 116, 113, 110. I just want to check one when it becomes smaller, 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 smaller. This is weird that it will become. Okay, so that seems like the closest we will get to 0.01, but why is here? Here's something that went. Sorry, I'm not looking for 0.01. I'm looking for 0.1. Where was my mind? I'm looking for 0.1, not 0.01, 0.1. Okay, 0.1. But yes, definitely mistakes on this table if I look at this, but let's 0.1. Okay, so that will be the closest that we will get to 0.1. So 1,28. So Z equal to minus 1,28. 1,28. Okay, so we've got that Z is equal to 1 minus 1,28. We will need to work out the X. So X minus 100. With a 15, we multiply both sides with 15. So minus 1,28 times 15 is minus 19.2 is equal to X minus 100. Then if I take this minus to that side, it becomes positive. So positive 100 minus 19.8 will give me 80.8. So X is equal to 80.8. And then the closest number to 80.8 is 81. And so if we put in 81 back into this, we will get 81 minus 100 divided by 15. That will give us minus 1,28. So that when we go to the table for minus 1,28, we will be able to get that value. Okay, so this is a very important one. Did you maybe have something like this in your assignment too? If not, please mark this as really important. It has happened in nearly the last 3 or 4 exams for stats that they had a question like this in. So question 28 in this pack is quite important for you to look at. I don't know. I don't think there was something like this yet in assignment 2, but it might be that in assignment 3 they include something like this. Okay, then the last 2 is looking at more definitions around the normal distribution. So the first one, okay, cool. Thanks, Ian. Yeah, so be on the lookout in your next assignment for something like that. And if you don't get it in any of assignment 2 or 3, then you will get something like that in the exam. So I will look for more of these for you that you can just then practice it a bit more. Okay, so let's look at a definition question. Given that Z is standard normal variable, the variance of Z is. Okay, so when it's standard normal deviation, that N is always the mean equal to 0, standard deviation equal to 1. Because that is 1, your standard deviation is 1, and your variance is 1. Okay, so it's the only time where it will be the same. Okay, so when it's normal distribution, your standard deviation and your variance will be equal to 1. Very important, because sometimes they can ask you, given that it is standard normal variable, the variance is equal to 1, but they could have also asked you standard deviation is equal to 1. And then it is nearly a catch and tricky question, because the definition tells us variance is equal to 1, but just remember, if we take the square root of 1, it stays 1. Okay. So in this instance, the variance will always be equal to 1. Okay, so option 3. And then another one that is looking at some of the theory, and what I thought interesting about this one, nearly a lot of the questions beforehand was the whole time which one is incorrect, and suddenly with a theory question they throw in, oh, which one is correct. And sometimes again, one is so set that you look for the incorrect one, and then you will probably choose the first one. The first one will maybe be incorrect, and again, it's not looking at what the question was. So we're looking for, in this instance, for the correct answer. Okay, so in here, in the normal distribution, the mean, median, and variance are all at the same position, the horizontal axis, since the distribution is symmetrical. Okay, so all that is correct except variance. So the mean, median, and mode are all at the same position. So that one is incorrect. But remember, we're looking for the correct one. In the normal distribution, the curve is asymptotic, but never intercepts the horizontal axis either to the left or the right. Oh, okay, big word. What that actually means is, if you look at that diagram, so it basically means there's a symmetry to it, and you can see always I try not to touch the line because it never intercepts that horizontal. Either left or right, it never intercepts that. So I don't think it was nearly visible on the, see, you can see there as well. It never intercepts the horizontal at all. So option 2 is correct, but I don't even think that was used at all in the study guide. So again, just some extra definitions that they use in this one. Let's just look at the other three why it is also incorrect. So random variable x is standardized when each value of x has the mean of x subtracted from it, okay, and divided by the variance. So that should have been standard deviation, then it would have been fine. And again, just as the formula is here, it said, okay, that we subtract the mean, but it should be just standard deviation and not variance. So that is why that one is wrong. Given that z is a standard normal random variable, a negative value of z indicates that the standard deviation of z is negative. Okay, not true, because we got that as variance, your standard deviation will always be positive. Okay, so that is, we will not, you can't get a negative standard deviation. Okay. What does happen, and we will see that in chapter 8, when we look at confidence intervals, we will subtract the standard deviation, but that standard deviation is still a positive number. So it looks negative because we say minus the standard deviation, but the standard deviation itself is never negative. So just on that point. And then the last one, the mean of any normal distribution is always 0. Okay, that is wrong. If you look at, it's only when we look at the z, where the z distribution, the mean is equal to 0. So not any normal distribution. It needs to be the standard normal variable. Then it is only 0. Okay. So that was questions or study unit 6. Okay, so what I thought, so I got some of the previous or assignment twos, some of the questions from Ian. So thanks for that. So I think we can start and go through that. Um, but if there's anybody from 1510 on the call, please just, or whenever you listen to it even later, if you can just send me your assignment as well, we can work through that as well. So if you get feedback on assignment two, please send that to me, um, so that we can also go through that, because again, 1510 and 1610 is so close to one another. Um, we can just as well use that, because it's also nice um, practice to look at that. Okay, so let's look at the feedback on assignment two. Again, if there's any new students on the call that's not on the WhatsApp group that wants to join the WhatsApp group, just send me a WhatsApp on 083-790-8387. Also for the guys that might have um, joined a bit later, please just, there is also the attendance register um, is also in the chat. So if you just can complete that. Okay, so let's look at assignment two, and it will also be nice for this 1510 guys to give me some feedback um, as how your marking is. We've seen in 1610, and thanks Ian for this, because you would see that sometimes you get feedback, and let's get to one of them that tells you that it's partially correct and you might not get the full marks. So what they've done in 1610, and that is for all your assignments, think about it as in the traditional way that you would have calculated something on paper. So what the lecturer is doing is he can see in your answer that you did a part of a question. And for that, he then basically give you a mark. Instead of you getting 0 out of 4, you might get a 1 or 2 out of 4. And that is just because in the olden days, if it wasn't multiple choice, you probably would have gotten those points, because you would have showed something for your how you would have gotten to the answer. So that is nearly how the lecturer would look at it and say, okay, but there's certain, well, not the lecturer, the system, that is the online system, it's built into that already. That there is questions that if you have given an answer that might not be correct, you might still get points. Um, so again, if a 1510 guys can just send me feedback on assignment 1 and 2, it will be nice to see if that principle is used in your environment as well. Okay, so let's look at one of the first questions of assignment 2. So they ask us which of the following statements is incorrect with regards to experiments, counting rules, and assigning probabilities. Okay, so in here they tell us, now they give us a few options. So they give us a permutation question, they give us a combination question, then they give us other options as well that we need to look at. Okay, so let's look at an experiment with 3 steps. and 2 outcomes possible for each step as 9 experimental outcomes. Okay, true or false? Okay, so experiment with 3 steps. So what I would have done is to draw it like this. So I've got my 3 steps, and each one has a possibility of 2 outcomes. Okay, so how many experimental outcomes are there? And I just want to, does it seem correct? So an experiment with 3 steps and 2 outcomes for each step. Okay, so there's 1, 2, 3, 4, 5, 6. Okay, so that should have been 6 and not 9. So that would have been the incorrect one. Okay, does that make sense? Does it not make sense? Okay, cool. Okay, so, and I think so it's the things that I think we sometimes we would have put a lot of work around permutations and combinations. Both of them are correct. So just remember to use the right formulas for that. But there's also permutation and combination. There's always on your calculators also that formula. So that I think is at least the the easy one is, so I've now worked out the permutations with a calculator and I do get 840. So on my HP it is already, there's a formula loaded for it. And then for combination as well, this is the right answer. So those two are definitely correct. Then in an experiment with 5 equally likely outcomes, each exponential outcome has a probability of 0, 0.5, 0.2. Okay, so that's also correct, because if you have 5, each has the same likelihood of outcome, it is 1 over 5, which is equal to 0.2. Okay, so that one will also be correct. Then a classical method of assigning probabilities is appropriate when all experimental outcomes are equally likely. That's basically what we have done here, is all of them are equally likely, so that is also correct. Okay, so that was the first one that we needed to look at. We looked at, and this is, if I look at these last two, much more in line with nearly the theory of the work. They've included combinations, permutations, and then nearly one that we could have done with a tree diagram. Okay. Next one. So interesting that I tell you that. Um, so they talk about the experiment and outcome. So suppose that experiment 4 of rolling a dice is conducted 3 times. Determine the total number of experimental outcomes and choose the correct answer from a list of options below. Okay, so this is interesting. Suppose experiment 4 of rolling a dice is conducted 3 times. Okay, so you roll a dice. You can now do this with, let's see if you can do it with 2 or 3 different options. Okay, so let me first get your thoughts on this. How would you have done it? So that is how I would have done it, but I don't. Ian, this answer here, I think that was only half right, eh? Okay, so I've got 1, 2, 3, 4, 5, 6. And then you roll the dice again. There's 6 of them, and then you roll the dice again. So there needs to be 6 of them. So I would have thought it's 6 times 6 times 6, which will give me the 216. Okay. And that is how you got that. So that's how I would have done it as well. It's basically you have this happening 3 times. So you've got 6. For each of those, there will be 6 outcomes. So, and then the next time again, 6 outcomes. So it will be 6 times 6 times 6. So what would that, how would we have gotten to 7 to 9? I just want to, 7 to 9 is also a weird one because how do you get to that? Because it's a non-equal number. So no, that will also not work. So let's just see. So it couldn't have been 3. It couldn't have been 6. And 18 is when you just say 6 plus 6 plus 6. Okay, so that is why 6 times 6 times 6 give you the 216. So why they given the other options or looked at? So again, remember that for your stats assignments, exactly the same as in the exam, there's about 2 or 3 or 4 even different papers. So one of the other questions might have been on one of these other options. And sometimes they give you the same answer. So it might have been that they would have just replaced it by saying experiment 5 is conducted 3 times, determine the answer or something like that. Okay, so they give you a lot of information, but it might just be because it is for another simulation of answers. Okay, so the first 2 was looking at probabilities, but more around if you understand how to work out the probability without bringing in too many other things. So I think what now is important is to look at a bit deeper insight into the probability. So here they tell us suppose that two events A and B have the following probabilities. So probability of A, probability of B, and then there is in the middle. So if we would have nearly made it like that, what happened here? So remember that piece in the middle will be the 0.35. Okay, so let's first look at independence mutually exclusive. So if it was mutually exclusive, the probability of A times probability of B would have been 0. So that is mutually exclusive. Events A and B are not mutually exclusive. So that's correct, because that should have been 0 if it is mutually exclusive. Okay, we're looking for the incorrect one. Events A and B are not independent. So A and B, if we multiply that and we get the and, we know it is independent. So 0.7 times 0.5 is 0.35. So A and B are independent. They say to us it's not. Okay, so that one is also, no, that's the incorrect, are not independent. Okay, so events A and B are not independent. Okay, we know it is independent, so that is the one that is. Okay, let me just read it right, but it doesn't confuse me now. Events A and B not independent. That one is the incorrect one. Okay, that one is the incorrect one, because for independent, we've seen that it is actually equal to 0.35. Okay, let's just look at the others. The probability of a complement of A is 0.3. Okay, that's correct. Probability of A or B, so we will get it as 0.7 plus 0.5 minus 0.35. So 0.7 plus 0.5 minus 0.35 is 0.85. So that one is also correct. And then A given B. So how I always try to remember this is we need to work out what's the probability of A and B divided by the probability of the last one, which is probability of B. So it is A and B is 0.35 divided the probability of the last one, probability B, 0.5. So 0.35 divided by 0.5 is equal to 0.7. Okay, so in this instance, all of them was correct except your last one, for independence. So again, what will happen probably between the different assignments, here something might have changed in what they give you, and then that might not change. So they might have said in this one that the probability of that and that one is 0 or something different. Okay. So given probabilities with, and they will always talk about the mutually exclusive and the independent. So just make sure that you know the ones around this. E for me, I needed to read it a few times um, to get the incorrect and the not independent, and nearly to get that linked. Yes, Ian.
How did we get C?
Okay, C, the complement, so 1 minus the probability of A will give you the complement, which is 0.3. Okay, so the complement is always 1 minus what the probability of A is. So 1 minus 0.7 is equal to 0.3. Cool. Any other questions on the probability set? So what we then normally have is that you get tables on this. So with the tables, in this one, they did not give you totals. So you would need to work out some of the totals. In your hand, is it an old hand? Or is there another question that... cool. Okay. Okay, so just then you can see they tell us there's 195 staff members. Those staff members are divided into from smoking nothing to heavy smokers, from managers to secretaries. And then again, they ask us which one of the following is incorrect. Okay, so how I would look at it again is I will not first go and work out all the totals, just because, again, it does take time. So I'll rather look at what the questions are, and then, if needed, add totals to it. Okay, so let's look at the ones where we only need to look at a random person is chosen. So the probability, so I'll first look at C and D, the probability that a random chosen staff member is junior employee is 0.456. Okay, so junior employee, so we need to add those together. So it is 18 plus 24 plus 34 plus 13. Okay, so 89 of them are juniors. So to get to the answer is 89 divided by 195. Okay, so 89 divided by 195 give us 0.5456, which is correct. Okay, we're looking for the incorrect one. Let's look at D, because again, that's just a normal one that we can work out. The probability that randomly chosen staff member is medium smoker. Okay, so now they're asking us to go down. Medium smoker, so 3 plus 8 plus 12 plus 34 plus 7 is 64. 64 divided by 195 is equal to 0.328. So let's just 64 divided by 195 will give us 0.328. Okay, so that is also correct. So the two easier ones done. So let's look at Then secretary and heavy smoker are mutually exclusive. So for that, it needs to be equal to 0. Heavy smoker, secretary. Wow, okay. Because it's 0, 0 divided by 195 is 0. Mutual exclusivity only happens when the AND is 0, so that is correct. Okay, the first time that I actually see a 0 in a table as well. Okay, so now we're sitting with 2 options. So at least if you now guess it's only one of the 2, but let's look at the probability. Oh, okay, so it's interesting. The probability that a random chosen staff member is junior. Where's that is junior? And a medium smoker. Okay, junior and a medium smoker. Okay, so junior and a medium smoker is 35 divided by 159. 35 divided by 195. And that is also correct. Okay, so then only sitting with option B, that must be incorrect, but let's look at it as well. The probability that a random chosen staff member is junior or a medium smoker. Okay, so how to get now that one? So remember the or, we will need to say it's the probability of junior, so the 0,456 plus the probability of medium, which we also luckily did, was 0,32328 minus the AND, which is 0,174. Okay, so to get to the OR, probability of a 1 plus the other one minus the AND. Yes, Ian.
It's A35 or 34.
Oh, 34, thank you. Okay, let me just now see if I still get to the right answer. Yes, okay. So I've spoken wrong, but at least I made the correct calculation on the calculator. So 34 divided by 195 gives us the 0,174. Okay. Okay, so for the OR, it is 0.456 plus 0.328, which gives us 0,785. But remember, we need to subtract the AND. So minus 0.174 gives us 0,61. Okay, so that is why option 2 is wrong. It should be 0,61. Okay, so what I did is I first looked for the easier ones to calculate. And when you can see, we actually only worked with junior and medium. So I didn't need to add all of the others and waste time. I just needed to work with what nearly was given to us. Okay. Questions on this? Okay. Then good to go to the next one. Okay. So again, they're giving us a smoking one. Sure. I hope but they told you at least, again, it is 195. Because if I only now say consider the smoking habits and you can't remember what the total is, you now need to work it out again, which is not great. So in this one, they ask us, what is the probability that a random chosen staff member is a light smoker? Okay. And that she or he is junior employee. So probability, like I said, light and junior management. So how I always remember it is light and junior management on the top divided by the probability of junior management. Okay, so light and junior management, so it's 24. So 24 to get that probability. So we can actual fact cancel the 195 now, but let's just, and the junior employee was 89. So unfortunately, if I now did it, if you didn't write it down, you probably now needed to work it out again, which is again not cool because it's wasting time. So hopefully they also gave you some of those totals. Okay, so the two 195 can cancel out, so your probability will be 24 divided by 89. 24 divided by 89 is equal to 0.2697, which is not one of them. Okay, that is not great. So where did I make a mistake? I looked at junior employees and not junior managers. I didn't even realize there was a different one. Oi, okay, so that was wrong. And that was wrong. So how easy it is to just assume I was working with some of the other stuff. Okay, junior manager and light. Junior manager, light, okay. So there it was only 3. Sure. 3 divided by that. How many junior managers? 4 plus 3 plus 8 plus 4. 19. Okay, so hopefully now 3 divided by 19 will give us 0.158. Okay. It is 0.158. Okay, very easily make the mistake now. I just assumed it is also junior employees. It's not, it's the junior managers. So I use the and from the light and junior managers, which is 3. I use the total of your junior managers, which is 19. So 3 divided by 19 gives us 0.158, which is option B. Okay. So the first one was a table to look that you can work out probability and mutually exclusivity, nothing of independence in here. Here they ask you to work out by working out that it's given something else. So the next one, so that was study unit 4, the probabilities going into study unit 5 now, where we're looking at a few other things. So now it is discrete random variables. So in this one, they didn't ask you to work out the probability. They've asked you to work out the expected value. Expected value, you basically work out by multiplying the x with the probability, and then you add it all up. Okay, so we can do it in Excel, but we can quickly do it in here as well. So 0 times that will be 0. So you will add it 0.23. That will be plus 0.28. That one will be plus what, 0.78, plus the last one, which is 0.72. Okay, so that then you will need to add all up so that you can get your expected value. Yeah, this can't really guess. There's nothing that I can really exclude until I have added all of them together. And I get it as 2,01, which is option C. Okay, for the ones that are not too difficult to work out the expected value, I just do it with this way, but you can go to Excel and type in everything. It will give you the same answer. And then in the end, you just need to add all of them together. So it seems like if you only added the last two, you would have gotten that. If you then added that, I don't know how they would have gotten there. Yeah, all the other ones, but it's for this one straightforward multiply out to get to your expected value. I would have expected now that they do. Okay, so now they've done the variance on it. So for the variance, now I would have gone to Excel. So let me just, I'm opening Excel. I just want to put in that values before I show it to you. So let me just quickly one. So you can also do it per hand, but then it does take more time. So let me just change the view here, zoom in a bit. Okay, so we've got the x's, we've got the probability. So if we worked out the mean, it would have been just those together. And the sum of that would have given us the mean. So let's just check. Okay, so there it is again. Then remember, if we work out variance, the formula for that variance is that I take my mean, I minus, or I take my value, sorry, my x value, I minus the mean. I think it is still square. And I just want to make 100% sure about this formula. And that I will need to then multiply by the probability. I need to do it for all of them, but wait, let's just let's see how many. And I just need to check if that is the formula. Okay, so it's definitely not the same answers. Let me quickly check what the formula is, unless somebody has a book with them. It might be that I've worked out the formula incorrectly. And so the variance for discrete is x minus the mean to the power of 2 times probability of x. Okay, so that is correct. X minus the mean that it is the mean of 2. Okay, this is strange. That is the variance. 0.9, 2.3, 1.4. Okay. Very strange that I don't get the same answer. Hey, anybody that can see what mistake I made? X minus the mean. And that mean was 0.01. Okay, so it is X minus the mean. Let's do it a bit differently. Okay, so that's X minus the mean. To see where this went wrong. Okay. So then it is that times that. And then it is that times that. Okay. Quickly. That minus that. That minus that. That minus that. Can't get the same answer. Uh, okay. Okay. Strange. I will check into this why I don't get the correct answer. And I'll get back to you guys on this one. Okay, let's just see if we can finish the rest. The building inspector would like to conduct an inspection of new built houses to check whether they comply with municipal regulation. The inspector knows that from past experience that only 8 out of 9 comply. Suppose that 10 newly built houses are selected at random. Okay. Assume inspectors are independent of each other. What is the probability that at most? So at most 5 houses. So what's the probability? Just 5 houses. So small or equal to 5 will comply. Okay, so we will need to look at n equal to 10. Just check where's our binomial. Okay, n equal to 10. So this is going to be a bit difficult, but don't worry, we'll do it. 0,8 was pi, so we're working with it from that upwards. So x is 0, 1, 2, 3, 4, 5. So we're looking at those 5 that we will need to add. So those 5 that we will actually need to add, because we say that it is 5 or smaller, or x is smaller or equal to 5. So x is smaller or equal to 5. Okay, so again, if this was printed, much better to work with. So it's 0,0264 plus 0.0055 plus 0.0008 plus 0.0001. Okay, unfortunately, that last one is 0. Hopefully, that doesn't have an impact on the answer. So my answer, if I look at that, I get 0,328. 0,0328. Okay, so option 3 is the correct one. So with this one, again, I go to the tables. If we look at the tables, remember at the top is we work for the probability smaller than 0.5. Then at the bottom, we work with probabilities from 0.5 to 0.99. Here we needed to work with 0.8. Then we look where n is equal to 10. we look at where x is smaller or equal to 5. So we'll see that we will need to add those. So when I look at it on the table, I need to add all of those yellow ones. And that would have given us then 0,0328. Okay, they also tell us it's binomial. So that was another hint for you guys. Okay, the one thing that might have caught you out is how do I get that pi? But in this one, they have hidden it nearly in the words. So out of past experience, 8 out of 10, which would have given us that 0.8 that we needed to look at. Okay, so that was binomial. I might ask you another binomial. So in this instance, they ask us, suppose that the random variable x is Poisson distributed. They give us the expected value of 2.7. Calculate the probability that x is equal to 3. Choose the correct answer from the list. Okay, so in this instance, they want you to look at what the formula is. I said we didn't need to work with a formula. They don't ask you to work out what the answer is. They just basically want you to write the formula down. So let's just look at what that formula was again. So if we go back to study unit 5. Let's just open that. Let's just see what the formula was. Okay, so they ask us, so if you look at that, so if you look at this, the easiest will be when you need to work it out. So all of them, actually the E minus 2.7. So I would have first looked at that part. But it already, okay, so that is, wait, there must be a nicer one. Where is the other formula? There's a nicer formula to actually work this out that's not in the book. I will mark that to you, but I can give that for you as well. Ian, since you had it correct, if you have that formula that you don't need to calculate all of that, I know there's a shortcut formula for this, else I would find it for you guys, that you can straight go to this. Sorry, it's Poisson distribution. Why did I look at? Okay, so let's quickly see. So there's the E minus the mean. So that was the 2.7 to the power of x. 2.7 to the power of x. And x factorial, so it's 3 factorial, okay, and then e to the power of 2.7. So what I would normally first do is look at that. Sometimes they give you other values. In this instance, they didn't, so all of those are correct. So unfortunately can't nearly eliminate any of that. So now we will unfortunately need to go to use a calculator. So 2.7 to the power of 3. Okay, so that gives us something like 19.683. And then 3 factorial means 3 times 2 times 1. So basically 19.683 divided by 6. That will give us a 3.2805. Okay, so I would first look at the e to the power of minus 2.7. Unfortunately, nothing could have cancelled it out. Then, unfortunately, again, does take a bit of time, but 2.7 to the power of 3 divided by 6 will give us the 3.2805. Okay, so we didn't need to work it out. We just need to substitute what's in the formula. I will, and I'll see if I can do it in the next few weeks. Create the whole formula page. I will just check where it is and I'll share with you for the rest of the study units as well, that you have that. So I will share that with the group. Okay. The next one. So now they actually asked only a few on proper binomial and Poisson. I would have thought it would have been more. Then we go into working with a Z. Here they are, so here they tell you, as in that other previous questions, normally distributed, mean of 0, variance of 1. So we know that it is a standard normal distribution. Then if we need to work out what the Z is, so remember that is 0 point, or is the mean of 0. So that is 0.5. Z smaller than 0.06. So just a bit bigger than 0.5. Okay, but if it's still bigger than 0.5, I think that is important. Bigger than 0.5, that's not part of our answers. That's not part of our answers. Just bigger than 0.5, that will not be one of our answers. So you're looking at two options that it can be 0.06. So let's look at Z 0.06, 0.06, Z 0.06, 0.5239, 5239, which is option A. Okay, so straight from the table for this one, they've given us the Z. We went to the table to get it. Nothing in that one that was too difficult. We could go straight to the table. Okay, so now look at what they've given. So it's interesting, they give you both. So they tell you the mean is 150, the standard deviation is 35, and they tell you now you need to work with this x smaller or equal to. So z smaller or equal to 170 minus 150 divided by 35. So 20 divided by 35. Really don't know why my PC is doing this. 20 divided by 35 is equal to 0.57. So if you work it out with a calculator, it gives you that, but we want to round it off to 2 because our Z table only works with 2. So that's why we work with 0.57. So Z smaller than equal to 0.57. So Z table, or sorry, the Z diagram, 0.57, smaller than that. So we know again it's going to be more than 0.5. So could have already cancelled those two out. Okay, 0.57, 0.5, 0.57, 0.7157, 7157. Okay, there is your option C for this one. So now they've given you all your values so that you can calculate the Z. From the Z, you can go straight then to the table. I just normally draw it so that I can see which ones I can nearly eliminate, but straight to the table, the Z was there for you to work with. Okay, so let's see what else is in here. So, okay, so here they are something like we also did in the study unit 6. So marks for assignment, first assessment, recorded an average 62, standard deviation of 21. So we could have seen it here already if we just do this, what they give us, 21. A total of 1,074 students submitted with first assessment. Assume that the marks are normally distributed. Approximately how many students have passed the first assignment with a distinction scored 75 or more? Okay, so this is a bit different. So approximately how many students have passed the first assessment score scored 75 or more? Okay, so we go for that score, 75 or more. So 75 minus 30 or minus 62 is 13. 13 divided by 21 is 0.7. Okay, so if we do this, okay, so again, remember that me is 0, here's the Z of 0.7. Okay, remember Z 0.7, so we're going to check what is this area, 0.7, 0.7580. Okay, 0.758. Okay, so if, and now to nearly explain what we need to do. So if this whole diagram is how many students there are. Okay, so if there's 100% of students, they will represent the 1047 of students. We want to see how many of them scored 75 or more, so we want this smaller area. Okay, that smaller area is 1 minus 1,758. So we know that the smaller area is 0,242. So what we want to find out is how many students fall within 24.2% of that total. Normally distributed, so we can basically say that 0,242 times 1047 will give us how many students fall into that yellow block. And if I look at that, why don't I get any of these answers? 1047. Let's see, that is 0,25. 0.7, let me just check. Okay, because my answer is 253. And so why don't we get that? Okay, this is interesting. I didn't, let me just quickly see. Z 75 minus 62, that is correct. Divided by 21, that is correct. 13 divided by 21. Ugh, how did I work out? Boy, that must be 0,619. So that is actually 0,62. Okay, Z 0,62. Z 0,62, 0,62, 0,7324, 7324, 7324. Okay, so that is actually 0,7324. So that area is not that. It is 1 minus that, so 1 minus 0,7324 is 0,2676. That times 1047 gives us 280, which is option 1. Okay, which is option 1. I think, okay, so Ian, the reason why you got some points but not the full points is because you worked out that portion. So you were doing the right work. You just worked out that answer was looking at this part with 0.7324. So that would have looked at this one. So that's why you got some marks, because you were doing it right. You should have just then said 1 minus that. Or, sorry, the 1047 minus that would have given you the 280. So 1047 minus 676 would have given you that. That's why you got half of the points or more, I think. Okay, so this one and this I've seen in all of the assignments and all the exams as well. So please look at this one very carefully. Very important one for your exam towards the end of the year. Okay, so that's it for today. Next week we'll continue, or we'll start with study unit 7. So next week we'll start with study unit 7. That will be part of your assignment 3. So definitely that will be the focus for next week. Okay, so that is it for today. Hope all have a good evening and stay warm. I will put the recording on face on YouTube as soon as possible. I'll share the link. I'll